Hi, I'm Belly from Greenwood Solutions. This week we're going to be looking at battery storage on-grid signage. Yeah, really boring stuff. Sort of ties in with our other boring presentation on Solar Grid Connect signage. But after watching this video, you'll sort of understand what signage to use. Now we're going to do a case study, 48 volt system, lithium iron phosphate batteries, and the rest is up to you. Let's get stuck into it. As CEC installers and designers, we need to operate under the appropriate Australian New Zealand standards, and this applies to on-grid battery storage systems. Look, signage is very important, and with the standards constantly changing, it is vital that the installer designer keeps up. The most commonly referenced Australian standard applicable to battery grid storage systems signage is AS New Zealand 5139 2019. So it's a fairly recent standard, which breaks battery systems into three different categories. We're going to be looking at the various signs required specifically for a Grid Connect battery storage system, but just the battery component, the reference Australian standards and the particular clauses relevant to the signage, the location and the equipment involved. Australian standards are living documents and therefore subject to change. This presentation is dealing with the current Australian standards and amendments, and we're not responsible for any changes in the future in regards to these signage requirements. Now we've got a case study example. So we're looking at an on-grid battery storage system that has a 1.75 kilowatt inverter charger, 2.6 kilowatt grid connect inverters, and 28 kilowatt hours total of a lithium iron phosphate energy storage system. So this presentation relates back to a job we did for Dye, and you may have seen the Dye story if you haven't checked it out on our YouTube channel. So we're looking at the signage specifically for this particular scenario. Switchboard signage, signs for battery system location. So in this situation, we're looking at the one standard, clause 7.4, and we're going to be putting this sign in the main switchboard and or fire control and indicating panel. But in our actual example, none, as the batteries are easy to find. So this is when the batteries are hard to find situation. Now, this particular signage, reference 7.3, clause 7.3, and the location is in the main metering panel and the MSB, so we'll need two. And this is a sign for energy storage label required at the main metering panel and main switchboard. And you can see that UN number 2, which indicates the actual chemistry of the battery involved. Battery enclosure room signage. So this is a restricted access signage. Just reference clause 7.5, and where you put this is adjacent to the battery enclosure, and you could add an extra one and put it on the door. So in this case, I've put two. Really, you only need one, but I think it'd be nice to have a second sign either on the door and adjacent to the battery enclosure or vice versa. Now this particular signage effectively indicates the short circuit current of the battery system and the max DC voltage, and it does go adjacent to the battery enclosure, and you could add it to the door, but we don't need the hazardous voltage sign because in our system it is 48 volts, which I should have mentioned before, and it's less than or equal to 60 volts. But we're going to be putting two in, one on the enclosure and one on the door. Now with this sign, it's effectively when we're talking about multiple BESS supplies. In our case, we don't have more than one, so we don't need this signage at all, but if we did, it would go on the battery enclosure and you could add one to the door. And the clause reference is 7.6. Now the explosive gas hazard. We do need this signage. Effectively, it goes on the battery enclosure or adjacent to the battery enclosure, and you could add an extra one to the door. Now the reference is clause 7.8 in the same standard, AS 5139 2019 model. So we'll have two in our particular situation. Toxic fume hazard. No, this is not your fellow installer. This is the potential for the battery chemistry that you're involved in venting toxic fumes. So you do include, in this situation, you will include it, and the reference is clause 7.9, and we put it again adjacent to the battery enclosure, and you could add one to the door. So I've said 2 for this. Chemical hazard. All battery system types categorised as chemical hazards shall carry a sign specifying what to do. In this case, we're going to do the old 1, 2 adjacent to battery enclosure and 1 on the door, and the clause is 7.10. You'll also need to reference the material safety data sheet. Arc flash. Now, arc flash is basically related to the voltage of the battery and obviously the current. In this situation, we are dealing with a battery that is classed as minor, and we do not need an arc flash sign. If we did, it would go on the battery enclosure, and the batteries we're using are individually fused, and if they weren't, we may need to go into the arc flash hazard signage area, but there's some particular calculations. So for future reference, look at clause 7.1 and look at table 6.1 in AS 5139, 2019. Battery system DC isolator. Now, the location of this sign is at or under the battery DC isolator, so obviously it makes sense. So we're putting 1 in here, and the reference clause is 7.12.2. Now this sign goes adjacent to the PCE, and in our case, we don't have multiple battery systems, so there's none. We don't use this sign in this particular scenario. Now the clause reference is 7.12.3. Now adjacent to each disconnector, now this is warning, do not disconnect under load. Now, because our project falls under the mantle of DVC/A, which is less than or equal to 60 volts, we do not need this signage. If you're talking about a 120 volt battery system, then you will definitely need this signage. Now the clause reference is 7.12.4, again the same standard as before. Shutdown procedure. Of course, every solar system, battery storage or no battery storage, requires a shutdown procedure. The clause reference is 7.16, and in this situation, it's adjacent to the PCE and the switchboard, so we're going to use 2 in this case. Spill containment. Now we're using a lithium iron phosphate solution, so there's no liquid electrolyte. Now if it was a flooded lead acid battery or similar, you would have this signage adjacent to the battery system, but in this case, there is no sign. The relevant clause is 7.19. This sign here is a combination of a few signs, and we don't need it because the signage requirements are covered elsewhere. If they hadn't been, we would be putting this adjacent to the battery system and possibly inside the battery cabinet as well. The reference clause is 7.2, again the same standard as before. Thanks so much for watching our presentation on energy storage on the grid signage, a riveting subject that ties in very well with our Grid Connect signage. Check it out if you haven't seen it. I'm Veli from Greenwood Solutions. If you like what you see, hit that subscription button, and that allows us to continue to make these videos. Bye for now.